Hello friends, welcome to today's session. Today's session we are going to discuss about CPU scheduling algorithms. Why there is a requirement of CPU scheduling algorithm we will discuss in this schedule. CPU scheduling algorithms are very much important in order to generate much throughput, and we want to see that the CPU is not going to be idle. So before we discuss about CPU scheduling algorithm, let us see that few important things. Who is going to do CPU scheduling algorithm, and what is the main necessity of the CPU scheduling algorithm, and what are the types of CPU scheduling algorithms are available. Before going into a deep lecture, let us say our anthem, that is crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription just a learning platform and access unlimited live and recorded lectures from India's topmost educators. About myself is Srinivasarao Sir, having 17 years of GATE experience in the subjects of database, operating system, and computer networks. Throughout my journey of GATE, I taught in many premium academies, including Medici 2, with high success rate. Taking the subscription is very much important, where you can get live and recorded lectures unlimited. You can have the lecture any number of times, and you can also discuss with the corresponding faculties to clarify your doubt. And there are many live quizzes are also happening. You know that mock tests are very important. They are the benchmarks to crack your GATE examination. So take the subscription, use my referral code to get the 10% off. This is about 12-month subscription, and this is about 24-month subscription. Use Sankara as my referral code to get the 10% off. Especially second year and third year students can opt for this 2 years program so that your confidence will be increased. Let's crack GATE CSC. Subscribe to YouTube channel and hit the bell icon for the latest notifications. Use my referral code Sankara to get the admission into an academy. Now, before we discuss about CPU scheduling algorithm, first of all, let us focus on to what is the meaning of degree of multiprogramming, and what is the link this degree of multiprogramming with our CPU schedulings. We know that real-time operating system nowadays we are using, it is nothing but time sharing operating system, also called as a multitasking operating system. It is an extension to your multiprogramming operating system. So what is the main motto of the multiprogramming is you can able to provide multiple number of programs into your main memory, and from there the CPU get to be executed. And in the multiprogramming, there are two varieties are there. One is non-preemptive based, the other one is preemptive based. Preemptive based is nothing but you see that there is a cycle between your ready queue and the run state as like this. In non-preemptive, once the process is assigned to corresponding CPU, then it is not going to be preempted unless and until you see that it has to be completed first, then only other process will be assigned to your CPU state. So whenever you do a concept of preemptive scheduling, there is a concept called contexting. What is the context? The context is nothing but last session we learned about a concept of process control block. Whenever you talk about a process control block, so process control block, last session we discussed, it is a data structure. It is also pinned to your process. It is pinned to process. Whenever a process enters into ready state. This is a very much important. So therefore, a ready state is nothing but, please observe carefully, a ready state is nothing but it is going to access some main memory. Therefore, your PCB is also going to be pinned to your process in order to observe the states of your process only. Sometimes the state will be in new, and sometimes the state will be in ready, and sometimes the state will be in run. So in order to observe that, your PCB is also going to be loaded, going to be pinned along with your particular process, and that's why you can say that it is also accessing some kind of main memory here. So therefore, so you see that the PCB is going to have few attributes. What are the attributes are there of your PCB? The PCB attributes is nothing but process ID. This is important. And the next one is process state. This is another very important. The states we learned in the last class like new, ready, run, and block. And we have the process priority. This is also very important, so that high level process or high priority process can able to preempt low level processes. And next one, you have the concept of a program counter. And next one, you have the concept of a list of open files, and you have the concept of list of open registers. So you see that all these attributes are filled with some kind of values, and these values are being changed time to time. That's why PCB is a per process. It is a per process. It is not for a global data structure. Your process table is a global data structure, but PCB is a local. Now you observe carefully. Here what is going to happen? I am going to fill the values because it is a table like this. I'm giving you process ID, and after that we have the process state. Then after that we have process priority, and so on. So here what is going to happen? Please observe carefully. So when I am saying that there is a process 1 which is initially into new state, and priority, I am saying that high priority. Now you observe, soon after this process is moving to next state, the second state is a ready state only. Then P1, the new is being updated with a new state called ready here, and with a priority same as like this. Now after that, the P1 is being switched to a CPU. That means it enters into run state with a high priority. Once P1 got successfully completed, then we understand that P1 is a terminated, then we can say that it is a completed. That means what is happening here? It is happening that your values or a tuples, this is also called as a rows, which are being changing time to time based upon the execution of the process. Therefore, you see that all these values of corresponding attributes is called as a context. This is a very, very important point. What is a context? Context is nothing but the values of the corresponding attributes which are there in your data structure called process control block. It is called as a context. So this context is going to be changed time to time whenever you go for multi-programming operating system. Therefore, here what is going to happen? You observe now, I will give you one small example. You see that P1 and P2, the CPU requires time. So I need to complete this P1. I need some time. So CPU I need for 4 units, and P2 also required some time, that is a 6 units. You please observe, both are running in time sharing concept. Time sharing is nothing but we know that it is going to be executed with a minimum guaranteed amount of time. So I'm saying, for example, 2 units if I am taking. Therefore, what will happen? You see that how the switching is going to happening between them. I say this is a ready state and this is a run state. Now you observe, initially the P1 will send to run state, So I need 4 units of time, but you could able to execute only 2 units only. So after execution of 2 units, again it come back into ready state. Now P1 has settled back, and now the P2 is going to join. It requires 6 units of time. Then it also, the maximum time is at 2 units, and the remaining time, you say that after executing of 2 units, we have the balance of 4 units. Again, the P2 will be sent back to ready state because we want to give a chance to this time P1 once again. Now P1 execute the remaining 2 units of time, so the P1 is being terminated. So here what is going to happen? There is a what loading of the process to the CPU is not fixed deal. Every time a new process is being attached to your CPU, therefore the context of the particular process is being changing. The context is nothing but the values of the corresponding attributes of your PCB. And I said that PCB is a local and every process has got this process control block. It is for per process, therefore inside values are being changing time to time. So therefore here what is going to happen? Sometime the process is in a ready queue and sometime the process is in a run state. Therefore, there is a switching between these two processes. First P1, then P2, again chance come to the P1, again goes to P2, again chance come to P1, again goes to 2. Therefore, what is going to happen? One time the process is in a run state, other time the process is in ready state. Again it is going to run state, again it is going to ready state and goes to ready and run. Therefore, there is some kind of switching is happening between ready queue and run state. This kind of a problem is called as what? As the context is changing, as the values are changing or context is changing, and this time this is called a concept of context switching. What is the context switching? Changing of the context of the process is a concept called context switching. So who is going to do this context switching? You can type from the comment. The context switching is going to be done using a concept called dispatcher. So dispatcher also sometimes we called as STS. It is the main responsible to do this kind of context switching. So what is the context switching, friends? The context switching is nothing but changing of the context time to time is nothing but context switching. So when we say that, what is a context? The context is nothing but values of attributes of a process. So this context is not a fixed unless and until you have only one process. If I have only one process, the context is not going to be changed except in round robin. In round robin, even single process also going to be changed its context. Now, what is the meaning of context switching? The meaning of context switching is nothing but it's very important. We want to bring the process back and we want to send the process to a run state. Therefore, context switching is nothing but switching among the processes. Switching among the processes is called context switching. Now you observe carefully what is the meaning of this context switching. And the meaning of context switching is nothing but saving the context of current process. Saving the context of current process and load the context of new process. And load the context of a new process. Therefore, what is the meaning of this? The meaning of this, I will give you one diagram you observe. So there are two processes are ready to run, P1 and P2. And first P1 has come into the picture. Therefore, P1 is occupied the CPU. So right now, as P1 is arrived first, then your P2, so P1 is occupied into CPU. Then after some time, P2 preempts as it is having higher priority. For example, you say P2 preempts P1. So when P2 preempts P1, how the context is being changed? You observe carefully. So initially, the P1 context I am running by CPU. As you are suspend that, then P2 will come back to ready. Sorry, the P1 is going to come back to ready state because the P2 preempts P1. Therefore, what happened? P2 supposed to occupy CPU and P1 is supposed to come back to your ready queue only. So P1 state is changed from run state to ready queue and P2 ready to run, the state is changed. Now the P2 is just moved to CPU in order to run it. Therefore, what do we need? We need to see that very carefully. When the P2 is preempts P1, then what you need to do is two things you need to do. What is that? Save the context of P1. Save the context of P1 and load the context of P2 and load the context of P2. This is very much important. Why to save the context of old process and why to load the context of a new process? Because as a new process would like to occupy the CPU and that too if it has got high priority than your P1, therefore what is going to happen? Your P1 is going to be suspended as you are having a low priority and the P2 is going to occupy your CPU and P1 will send back to ready queue as P1 is not completed its execution, still it is pending only. So that's why you need to save the context of the process. What is the context of the process? Now you understand carefully. When is P1, when P1 is now moved to CPU after completion of P2, then the P1 is supposed to once again go back to from ready queue to your CPU state. Please observe. So initially the P1 is in a CPU and the P2 suspended, then simply you will send back to ready queue and after some time when the CPU becomes idle from ready queue again you need to go back to CPU state only. Therefore, I need to save myself that up to where I have got completed my process. The real time example you see that if I am watching a one movie then I completed up to some half of the movie. In the meanwhile you got the call. Therefore, what is going to happen? Your movie is paused for some time so that you can able to talk with others. After completion of the second process, here second process is nothing but getting the call from somebody. First process is nothing but watching the movie. So your watching the movie is being paused for some time because high priority call has come. So you just after talking the call again you can continue your process. So don't think that you are going to watch the movie from starting because already half of the movie is completed, so we will continue from that particular half only. So that's what is the meaning of that continuing from that part is the concept of what saving the context of the process P1. That's very important. If you once again it come back to and start from the start, it is a meaningless because we are using the concept of a context switching such that the process can move from ready to run and run to ready, but don't think that again you are going to start from the scratch because the context switching is going to helpful in order to what I mean to say save your context. So that's why what is the meaning of that? Save the context of the process and load the context of a new process. So there is a other important point is that apart from this context saving, program counter also playing very important role. For example, I have watched a movie up to exactly half. Then the program counter, whenever you get the suspension from higher priority process, then program counter will take the next seconds of time after completion of your half of the movie. So that information is loaded in program counter. So whenever you got call back, after completion of your callback, whenever you come to watch the movie, your movie is going to be started from the instruction in which the program counter is consisting of. So from that particular point only, the particular program is being executed. That's the meaning of context switching. So here, what is the meaning of that? So we know few important things. after so far discussing what is a context, we understand what is the context switching. So whenever you do context switching, you please observe few important points. What are the few important points? PCB is updated. Please understand. All the values are updated and your program counter is set with the next instruction. Is set with next instruction at right now where you are paused and immediately next instruction is going to be placed here, and after that you need to save the PCB. And the next one is, if there is any TLB, flush the TLB. Translation, look at aside buffer, which is also called as, sometime we people generally called as cache. It is going to be cleared. So these are the important things you need to take care whenever you're switching process from two important states. That is a ready state and that is a run state. What's going to happen? So the process may come back to ready state. After some time, the process may go back to run state. So we don't want to start from the scratch of the program. We want to see that from where the suspension happened, from there the point the program has to be continued. So who is going to do this context switching? As I said that the STS, short-term scheduler, sometime also called as a dispatcher, is responsible to do this kind of context switching. Okay, friends? So observe carefully, what is a context? Context is nothing but the values of the attributes of the corresponding process is called a context. The context of the process is stored in process control block. Each and every time when the process is moving from one state to another state, the context of the process will change. It means context switching may happen. If context occurs, then if keep on happening context, then what is going to happening? Overhead is going to see. For example, first P1 is in CPU, then P1 is killed by P2. Then P2 occupied CPU. I am writing here. Then P2 killed by P1. Then the P1 is occupied by CPU. Then after that the P2 is entered. Then after that the P1 is entered. Then after that the P2 is entered. See how many times they are killing each other or preempting each other. Therefore, what is going to happen? Just the CPU is busy in context switching only. So therefore, you see that there is no productive work in this case. Productive work in the sense CPU, in order to execute the process, it's going to be busy in doing of this kind of a context only, which leads to a concept of what? Overhead, which is undesirable. So what is the meaning of context switching? Context switching is nothing but saving the context of one process and loading the context of another process. This is what is the meaning of context switching. If you not save it, then your previous process is going to be terminated. That's why we do not want to terminate. We want to keep it in the buffer. The keeping in the buffer is nothing but your PCB is updated and program counter is updated. The next instruction is ready to be executed soon after the arrived process is got completed or terminated. So therefore, it is a mandatory saving the context of the process and loading the context of arrived process is a concept of context switching. So if context switch happen, what to do? The system, operating system is going to do these steps. What are that? Saving the current register values and change the address translation tables and flush the translation look at buffer and save the general purpose registers, update the program counter, update the PCB. This is what. So I am telling you once again, whenever a process is entered into the ready queue, your PCB is also tailed to that particular process in order to identify that these kind of changes and fluctuations may happen. That's why a PCB is always tied to your particular process whenever it is entered into a ready state. This is a very important point. And the next point is, we have two types of processes. This is very important. What are the two types of processes? CPU bound and IO bound processes. What is the CPU? CPU bound, when you talk, a process requires much more time of the CPU. That means it is CPU hold with only one process. That process is taking much more time of the CPU only. So CPU bound processes are nothing but, if a process is occupying if a process is occupying more time with the CPU, then it is a CPU bound process. So what is the problem with the CPU bound process? And it is see that starvation to other processes. Starvation to other processes. You can say that and a particular instance of time we able to execute only one process. Therefore, you say that the throughput of the CPU is less. Throughput of CPU is less. So what is the throughput? The throughput is nothing but average number of processes executed per instance of time. If I am saying that the P1 is keep on busy with CPU, other processor not going to be given to CPU, therefore you see that for a given instance of time, I could able to run only one particular process. So your throughput is only one in that case, because the particular process is occupying the CPU much more time. So the other variety process is called IO bound process. What is the IO bound process? When we talk IO, it is nothing but input and output only. IO is nothing but input and output. Input and output device. Now you observe carefully. When a process is taking a much time of IO, then it is IO bound process. What is the problem? The very important problem. What is that? During IO, then what is going to happen? The CPU is idle. This is very important. During the IO processing, the CPU is idle because the process is busy with IO only, then CPU get to be idle. So when the CPU get to be idle, what is the problem? Yes, there is a big problem. What is that? CPU utilization is very less. CPU utilization is very less. So that's why you see that there must not be completely CPU bound process. There must not be completely IO bound process. We want to take the combination of CPU bound and IO bound process. Therefore, you see that the CPU is not going to be idle, and you also see that the only one process is occupying by CPU is also can be avoided. So you need to take the good combination of CPU bound processes and IO bound processes. Therefore, you are going to achieve much throughput as well as reducing of your CPU idleness is also possible. I will give one example, you observe carefully. I am saying there is a process. I require the CPU time. Please see. I don't want any input and output. Just I am watching the movie. You execute. You see that is example. I am watching the movie. So when you are watching the movie, what is going to happen? P1 requires 3 hours time. Then other particular process is entered. It requires 1 minute time. And other particular process which require only 0.minute time. So you observe that. So this is a completely CPU bound process. Why I am saying it is a CPU bound process? Because it is taking almost 3 hours time only with the CPU. Unless P1 is got completed, please again I am telling you, unless P1 is got completed, this 3 hours of time and P2 cannot be executed by CPU and P3 cannot be executed by CPU. Therefore, the P2 and P3 are going to be under starvation only. And one more thing I want to tell you, uh, within the 3 hours of time, your average number of execution your average number of executed processes are only one, because the 3 hours only one process is occupying by CPU, hence your throughput in this case is only one for 3 hours of time. That's why we do not want to see these kind of examples in real time, because in real time you're having the combinations of CPU bound as well as IO bound processors. And next example I want to tell you about IO. So here what is the problem? The problem is that throughput is equal to only one process for 3 hours of time. So for 3 hours of time, you see that only one process we are able to execute, because the process 1 is taking a much more time with your CPU. Now you see second variety, IO. What is IO here? Please observe. Now I am talking about IO bound. So earlier one is CPU bound. It is a bound to CPU. That's the meaning of CPU bound. Now you observe here, process number A is the process. I require CPU time only 1 unit, but I require IO time, please see, 300 units. Now what is going to happen? So as soon as A enters into ready queue, then immediately it is being handed over to your run state. So run state is nothing but, please observe, we are accessing main memory as well as CPU. Here also we are accessing main memory. Now after executing your A process A for 1 unit of time, then immediately there is a requirement of what? IO to me. So it enters into IO. So IO request given. It enters into IO. Then the IO A requires, it is almost all 300 units of time. So during the IO of process A, what the CPU is doing? CPU kept idle because its no work is done by CPU. Because unless and until I completed this 300 units of the process A, because I don't have other processes, therefore the CPU kept idle. This is the problem. Therefore you see that unless and until you complete your IO, then again you cannot go back to run state. Therefore you see that your CPU is going to be under idle. So this problem is a main problem. What is that? CPU idleness. CPU idleness is increased if you are having a concept of IO bound processes. So finally friends, what I want to tell you, I want to take the good combination. I want to take the combination of, it's not a normal combination, good combination of what? CPU bound we want to take, as well as we want to take other parameter. What is that? IO bound process also we would like to take. So when you are taking a CPU bound and IO bound processes together, then two important things you are going to achieve. One is that CPU idleness is being decreased, and the other one is that CPU throughput is going to be increased. Throughput is nothing but I can able to run multiple processes an instance of time, and the CPU idleness is nothing but when one process is in IO, immediately I can push other process to your CPU if you are having. So these are the two important things we are achieving by taking the good combination of CPU bound and IO bound process. So who is responsible to do this kind of selection? This is very important. Who is responsible? Who is responsible to do this work or this task? What is the task? What is the task? A good combination of CPU plus IO bound. There is a one component. What is that component? Long-term scheduler. Long-term scheduler is responsible to do this kind of a task. Its responsibility is that it will take the combination of IO bound and CPU bound process in prior than the other particular processes. Now we come to the very important another point is that scheduler. Scheduler is nothing but scheduling of the process. Scheduling of the process, that is creation and scheduling is done by these schedulers only. So three important tasks of your schedulers. Your scheduler tasks, they are also software only, software components they are. What is the task of that? The task is nothing but what? Creation of the process, creation of the process of one task, and scheduling the process is another task, and one more task is there. What is that? Suspension. Please observe, suspension of the process is also another task. So these are the tasks of your schedulers. So schedulers are nothing but built-in available with your operating system. They are your softwares only, which consist of what? Creation of the process and scheduling the process, and the suspension of your process is done by these schedulers, and these schedulers are by default available in your operating system. They are implicitly available in your operating system. So what is the role of each scheduler, like long-term scheduler and short-term scheduler and mid-scheduler and dispatcher? We will look at here. Now you see, when we are talking about a long-term scheduler, the use of long-term scheduler is nothing but its main responsibility is creation of a new processes. Creation of a new processes. It is called as job scheduler. Please observe, friends, the synonyms are also very important. What is the other name of your LTS? Long term scheduler it is. The other name of LTS is nothing but job scheduler. Long term scheduler. It's keep on bringing the process for the execution. That's what. The creation of the process is a continue process. Creation of a new processes is continuation process. It's a never ending continuation process. It's a never ending process. That's why it's a lifetime is a long time. That's what very important. So its a lifetime is a very long. Its lifetime is very long. That's why it is called as a what? Long term scheduler. What it can do? I gave you three tasks. What is that? Creation of the process and the scheduling of the process and the suspension of the process. So in that it is responsible for what? Creation of the process. So the operation is done by long term scheduler is nothing but creation of the process only, and its lifetime is a very long because the creation of the process is a continuation, a concept. So keep on process are going to be created. So what is the other important thing? This is a very, very important point. What is that? It controls the degree of the programming. It controls the degree of multi-programming. The degree of multi-programming. So the degree of multi-programming depends on your long-term scheduler only. And one more important that it is responsible for what? A good combination. It is responsible for identifying CPU plus IO bound processes. Therefore, CPU throughput is increased and the CPU idleness is going to be decreased. So in CPU bound process, you see that throughput is being reduced. If you are having IO bound process, the idleness of the CPU is being increased. So therefore, we want to take the combination of these two. That is one of the responsibility by your LTS. So long time, lifetime of the LTS is very long because the creation of the process is a continuous task. And the next we have short-term scheduler. This is a very important. Its lifetime is a short only. Short-term scheduler. It is called as CPU scheduler. So it is responsible for sending the job from ready to run. Earlier, please observe carefully. Earlier, LTS is responsible for construction of the jobs, but here, what is the responsibility of the CPU STS? That's nothing but what? Sending a jobs sending jobs from ready queue to run. So this is the responsibility of your STS. So the processes which are enters into ready state, they will be sent back to your CPU in order to execute them. That's why it's a responsibility just sending the process and leave it. That's why the lifetime is a shorter. The lifetime of short-term scheduler is very small. This is what is the concept of STS. Its main responsibility is nothing but sending the process from ready queue to run state. That's it. And this is also called as what? CPU scheduler, because it schedules the process for the running and it is going to hand over the process to your CPU only. And what is the next one? MTS. So the third scheduler is MTS. So LTS responsibility, creation of the process. STS responsibility, scheduling the process to CPU. Please understand, scheduling the process to CPU. Scheduling process to CPU. This is the second task. Third task, you know, what is that? Suspension only. Who is going to do that suspension? MTS. So MTS is called as medium term scheduler or mid-term scheduler. What is its responsibility? It is for suspension and resuming. Its task is suspension and resuming. It is responsible for suspension and resuming of process. That's why its lifetime is better than your STS, because sometime it is suspended, sometime it is being resumed. So lifetime of MTS is medium. What is the other name of MTS? It is called as what? Swapper. Please understand the other names. LTS is a job scheduler, STS is a CPU scheduler, MTS is called as what? Swapper. What is a swapper? It is trying to suspension. It can be suspended from run state, it can be going to ready state, it can be suspended from run state, can able to enter into block state. And swapping, now we want to learn. What is the swapping? Please observe, friends. Very important question. Swapping. Who is going to do this swapping? The swapping is done by MTS only. MTS other name is called swapper. What is that? You see that process P1 is executing currently. Process P1 is executing currently. Executing means what? Right now the process P1 is in CPU. Please see that the P1 is into IO state. IO state is nothing but what? Block or wait state only. Please understand. IO state is not nothing but block or wait state. I want to tell you here, if IO is completely filled, then what is going to happen? Last session we learned, and the P1 enters into what? Suspension. P1 enters into suspension. So who is going to do this suspension? The suspension is nothing but, you please observe, bringing the process from main memory, sending back to secondary memory. Observe carefully. There is a secondary memory, because all your programs are available in secondary memory only, hard disk. From secondary memory, we try to run with the help of your main memory, and so therefore the CPU could able to execute your process. Now observe here, P1 is available in second memory. It is just placed onto your main memory. This is your RAM main memory, and P1 is available. And sometime it is with CPU, and if at all it comes back, now we want to do, because of IO, when it comes back, Again, when it is having a suspension, then what is going to happen? Immediately it will send back to your secondary memory, because we are not going to waste main memory resources with that, as it is already suspended. Therefore, what are we doing? We are doing two important things. What is that? Bringing the process from secondary memory to main memory is concept called swapping, and bringing the process from main memory to secondary memory is called as what? Swap out. Again, I am telling you, suspension and suspension resume. Please understand, suspension and suspension resume. Suspension is nothing but bringing the process from your main memory and keep it in secondary memory. Therefore, the particular process is not on your main memory now. Once you resume back, then again the particular process will come and occupy your main memory. That's called swap in. So this swap in and swap out is done by swapper component. So that is done by midterm schedulers. So please observe here, what is a swap in and a swap out. Sometime the process is in main memory. Assume there are two processes which are there in your secondary memory, and this is your main memory. So if I am keeping this particular process onto your memory, it is called as what? Roll in, also called as a swap in, sometime P1. Then if you are bringing this P1 from here to there, it is called as a rollout. Why? Because we want to occupy this time P2 here. So that's why it is a concept of what? Swapping, suspension and suspension resumption. So friends, we learned three important schedulers. One is a job scheduler, also called as a job creator, and it is a main responsibility of what? Degree of multi-programming. And the second one we learned short-term scheduler, also called as a CPU scheduler, sometimes also called as dispatcher, who dispatch the jobs from ready queue to run queue. It is called as a dispatcher. And the next one is a midterm scheduler. It is a concept called as what? Swapper. It's a main responsibility to do swapping. That means swapping is nothing but bringing the program from secondary memory to main memory and from main memory to secondary memory. So what is the meaning of dispatcher? We will learn here in a special definition. It is a software program. This is not only a software program, others are also software programs like LTS, MTS, STS. This is also, sometimes it is also being treated as a what? Dispatcher only. So who is decided to send the process to your CPU? The dispatcher is responsible for what? Saving and loading the context of the process. The context switching is done by dispatcher. We already seen context switching is nothing but saving the context of the current process where you have been suspended, and loading the context of a new process. After completion of that process, again we want to start our old process. That's why there is a mandatory requirement of what? Saving the context is very important. If you not save the context of the old process, you cannot able to resume back it soon after completion of the new process. So now we come to CPU scheduling. So what is the CPU scheduling? Who is going to do the CPU scheduling? As I already told you, CPU scheduling is done by short-term scheduler. Sometimes it is also linked with your dispatcher, because the dispatcher is responsible for what? This kind of loading the context of the new process and saving the context of old process. That is done by your dispatcher. So both together, STS and dispatcher is together is doing the concept of what? CPU scheduling. CPU scheduling is nothing but what? Sending the process, which process I need to send to the run, send it to the CPU is the concept of CPU scheduling. So why to do CPU scheduling? Let us see. So CPU scheduling is nothing but sending the process from ready state to run state. So if there are 10 processes are there, which process I need to allocate to the CPU? That's very important. Which process I need to allocate the CPU? That is decided by the CPU scheduling. If only one process, if it is a uniprocessing system, then there is no concept of CPU scheduling. CPU scheduling is only for what? Multi-programming operating system only. Again, I am telling you, please understand. If it is uni-programming operating system, there is no concept of CPU scheduling algorithms, because you will see that only one process is going to be executed at a time. Whenever you see that multiple processes have come to the ready queue, then only there is a requirement of CPU scheduling. Which process we need to accommodate to the CPU is important task. So what are the goals of CPU scheduling? Increase the CPU utilization and also the throughput of the system. This is important, and it all reduces average waiting time and average turnaround time. This is another very important. When there are multiple number of processes are there, we want to reduce average turnaround time and average waiting time, and we want to see that fairness and efficiency. This is very important. The main idea of CPU scheduling is nothing but what? Decrease the response time. What is the turnaround time? What is the waiting time and the response time? We will see now. So who is going to do this kind of decision? We already know. We already know the only one scheduler among the three schedulers, STS, LTS, MTS, who is going to do this? The only one guy is going to do. That is called as what? STS, short-term scheduler, along with your dispatchee. Now you see, who is going to do? Short-term scheduler is going to do this work. When from ready queue to run state. Its main responsibility that if there are multiple processes are there here like P1, P2 and P3, I need to see that which process I need to take care and assign to your CPU. That is the point of your CPU scheduling. Again, I am telling you, if there is a single particular process is available, there is no requirement of CPU scheduling. But in real time and real time scenario, multiple programs are available in your ready queue. Now I am in ambiguity which process I need to send it to the CPU. That's a very important task. So that is done by your STS, short term scheduler. So when a process is, please understand, I will give you process state diagram new here, and this is your ready queue, and this is your run state, and this is your terminated state. Please recollect the last session diagram. And you also have, if there is any IO, block and wait is required. This is in the event of IO request. If your IO is completed, again you will go back. You see that IO got completed. Now this is like this and this is like this. You observe carefully. In what are the cases that CPU scheduling is done? This is a very important question. In what are the cases the CPU scheduling is done? Few important cases. What is that? Please see. When a previous process is completed and enters into terminated, then again, which process I need to schedule from P1, P2, P3? P1 if already enters into terminated state, immediately the ready queue will send to the other particular process to your CPU. This is the responsibility of STS. That means once it is terminated, then immediately next process to be scheduled. And next one, if the old process enters into block and wait state, then CPU kept idle. Then immediately STS is responsible to put the new process into your run state. So run to wait and run to ready. Run to ready is nothing but what? In the event of preemptions or timeout expires or priority, your switching between your run to ready is going to happen. So in that case, immediately I need to see that which process I need to keep it here. There is a run to ready, and the next one, new to ready. Whenever you are sending a multiple process to ready state, then ready queue has to decide which process I need to schedule to your CPU. So new to ready. Next, wait to ready here. So once you give IO request, it comes to block and wait. If IO is completed, again that particular process comes to the ready state, and you need to see that which one to be scheduled here. So these are the different cases when the CPU scheduling is happening. But you observe carefully, all are linked with the ready queue only. Observe carefully. Whenever they comes to the ready queue, then the process is going to start. which process I need to assign to CPU. That's why all are linked with ready. Run to termination. Once soon after run to termination happen, ready queue will push the process to run state. Run to wait. So run to wait, then immediately one more process is going to link it to your CPU. So likewise, in these are the cases the CPU scheduling is happening, the remaining cases it's not happening. So finally, I want to confirm here one important point. Long-term scheduler is responsible for creation of the jobs which occupies main memory. Please observe carefully. These jobs are created from secondary memory only. Please see. All the jobs are available in hard disk. From there I start executing the jobs. When it comes from new state to ready queue, we are occupying main memory here. Who is responsible to do this? STS is responsible to do this. When it comes to run, then CPU, it is occupying CPU resources here, and it also access the address tables of your main memory. So main memory also going to be used here. When it comes here, then IO request, and when go back, this is how it is going to happen. If there are any suspensions, please observe. If there are any suspensions, double arrow. If there are any suspension, double arrow means what? Suspension and suspension resume. That is done by your MTS. Observe carefully. Suspensions are done by MTS. So here also, if there are any suspensions, both sides, suspension resume and suspensions, this is also done by your MTS. Please observe carefully, friends. When a process has come back, you are entering into what? Secondary memory only. Please understand carefully. It is out of main memory. So main memory you will have a new processes and ready queue and CPU and main memory and block and wait. It is also what? Accessing main memory and with the help of what? IO devices. Please observe. So main memory occupying by three different positions. One is LTS, that is a new state, and the other one main memory, that is at ready queue, and the other one main memory is at a CPU, the other one main memory at block and wait. The remaining cases it is with the secondary memory only. This is an idea. If any doubt, please post, friends. Up to here, any doubt? So what I said finally, friends, observe carefully. Which are in main memory? That's important. Which states are in main memory? New state, ready queue, then CPU, block and wait. These are in main memory. And next one, when you are talking about a new, it is done by LTS. When you are talking from ready queue to CPU, which is done by STS, and this is in where IO request and IO reply. And next one, who are in the secondary memory? Two states. They are called as what? Suspended from ready. Please recollect last session diagram. Suspended ready, and the other one suspended from block or wait. So due to lack of the IO resources and due to lack of the ready queue, because queue is a limited length only. So in these two cases, you say that MTS is responsible to do swap in and swap out, and whenever they are swapping, it deals with the secondary memory, not with the main memory. So main memory is only available in these two cases. So come to CPU scheduling policy selection. So the policy selection is independent and the configuration of your CPU only. This is very, very important. It's not equal to all the processors. It's not equal to all the system. System by system, the CPU scheduling policy is being depends. It's not fixed. And it is based on arrival time and job size and priority and time sharing. Arrival time is nothing but what? For example, among the three process, I'm talking about arrival time. So it has come at 0, it come at 1, it come at 2, it's arrival time. So which process we are going to assign? P1 will assign first, then P2 will assign next, then P2 is going to assign that. That's based on what? Arrival time. What is the job size? Smaller jobs are going to be executed first. What is the priority? High priority process will execute first. What is the time sharing? This is a multitasking and round robin fashion. Every process is going to be executed for a given fixed amount of time slice. So based on that, the CPU scheduling is depends. Now, every process is related with the following times. Please observe, friends. So I want to highlight this. This is very, very important. 1 mark guarantee gunshot question. What state at what memory? Whether it is a main memory or secondary memory. And which state belongs to which scheduler? Please understand either LTS or MTS or STS. This is very, very important. Please send to as a screenshot to your mind. And this is also very, very important. How scheduling is being done. Scheduling is being done using one arrival time concept, or smaller jobs are executed first, or high priority process will execute first, and time sharing. Based on time sharing also CPU scheduling is done. We will see all of them. But before that, we learn about few important time relations. So this is arrival time of the process. First one, arrival time of the process into which one? Arrival time of the process into which state? A new state or ready state or run state or IO state? Just type a comment from there. Arrival time of the process into which state? It's a very simple. What is that? Ready queue, ready state. Arrival time of the process. Next one, soon after completion, completion time of the process. Next one, burst time. How many CPU cycles required? CPU units. Sometime IO also required. IO units. That is the concept of burst time. And what is the turnaround time? Turnaround time is nothing but how much time the process is in execution from your arrival time to your completion time is the concept of turnaround time. Please observe. When a process enters into the ready queue using one arrival time, we want to see that at what time it is being completed. If the length of or the difference between your ending point and starting point is what? Your turnaround time only. Please understand one important thing here. So, process 1, arrival time is a 1 and your burst time is for example say 5 unit CPU required. CPU burst time and it is being completed at 7 if I am saying like this. So what is the turnaround time here? The turnaround time is nothing but ending time of the process minus starting time of your process, that is CT minus AT only. So during this time, during this CT minus AT, the process may be with the CPU or the process may be with what? Waiting. Please understand. I may not be immediately scheduled to CPU. I may be also having some kind of waiting time. Therefore, you observe that, see, during this particular period, CT minus AT, I may directly utilize the CPU or I may wait for some time to enter into CPU. Then I will take what? CPU time. Therefore, during this particular point, one point to other point, you observe that the process may be with the CPU or the process may be in waiting. That means it not enters into the CPU. For example, you say 2, I say that burst time is 3 and completion time if I am saying 10. Then here what is going to happen? Unless the first process is completed, the second process cannot be executed. Therefore, here there is a waiting time to process 2 because unless and until 1 is completed, 2 cannot execute. Therefore, here the P2 sometime is in waiting and P2 sometime is in execution. That's why every process may or may not have the concept of waiting time. So here friends, turnaround time is nothing but completion time minus waiting time, and arrival time. What is your waiting time? Your waiting time is nothing but, please look at now. Waiting time, how much time the process is under waiting before it get access your CPU. That's what waiting time. How much time the process is under waiting to get access your CPU time. So your CPU time is nothing but what? Burst time I'm talking. So CPU time is nothing but what? Burst time only. Now you see your turnaround time is nothing but CT minus AT. CT minus AT is nothing but what? Sometime you are executing by CPU, sometime you are under what? Waiting time only. So what is your waiting time? Your turnaround time minus your burst time. You are going to get what? Waiting time. Because please understand, this is your turnaround time, ending time minus starting time. Ending time minus starting time, you may be with the burst time or you may be with some waiting time. So CT minus AT, that is a turnaround time minus your burst time, is a concept of what? Waiting time. So next one is a response time. What is the response time? The first hit by the CPU, the first hit by the CPU minus your arrival time is the concept of what? Response time only. So we want to see that the response of the CPU about your processors, it is a different from process to process only. You have arrived at some particular point, but CPU is not hit you. So when it is going to first hit, when the particular CPU hit the process minus your arrival time is a concept of what? Response time. The goals of CPU scheduling algorithm is nothing but what? Many of you people understand that response time to be increased, but it is a false. Response time must be what? Decreased. To decrease the response time, we are using the concept of what? CPU scheduling algorithms. So therefore, our main task is nothing but what? Your response time is nothing but first hit by CPU. First hit by CPU minus your arrival time, that is response time by the CPU, and the main CPU goal is response time to be what? Decreased, not to be increased. Okay friends, so we come to today's point. What is that? CPU scheduling algorithms. A small recap. Who is going to do this CPU scheduling? Please understand, the CPU scheduling is done by STS plus there is a component called dispatcher. The main use of dispatcher is saving the context of old process, bringing the context of a new process. And a short-term scheduler is try to allocate the particular process to CPU. These are available with your operating system only. So CPU scheduling algorithms, though, how the process is being scheduled to CPU is the concept of CPU scheduling. It is done by four parameters I already told you. One parameter is what? Based on arrival time, and another parameter is what? Based on job size, whether you want to send smaller jobs or higher jobs, and this is based on first come first serve fashion, and this is based on shortest job or longest job, shortest job or longest job, and next one priority, high priority or low priority. So these are the three parameters are there in order to schedule your job. Apart from that, your time quanta, that is nothing but what? Time slice. So you observe that all these algorithms whichever I mentioned are based on these parameters only, nothing else. These parameters only, nothing else. You observe first come first serve based on arrival time. SJF and LJF based on job size. Please observe carefully. Priority is based on priority parameter, and HRRN is also similar to first come first serve, and SRTF LRTF both are based on job size, and priority we know that it is the priority parameter. Round robin time slice, and multi-level queue scheduling, this is based on by mixing all these parameters you can say that multi-level queue scheduling. Therefore friends, only four parameters are there in order to do the CPU scheduling. These are the four parameters. time slice, arrival time, job size, and priority. Now, your CPU scheduling algorithms have been categorized into non-preemptive based and preemption based. We know what is the meaning of that. When you talk non-preemption, others must not kill me or suspend me. That's what. Others must not suspend current process. I want to tell you another very important thing. What is that? Resources must be deallocated. Resources must be deallocated voluntarily. That's the meaning of this non-preemptive. Resources must be deallocated voluntarily. When they are going to be deallocated? Only after completion only, right? Only after completion only they are going to be released. That's what the meaning of non-preemption. If you take the preemption, somebody can preempt you. High priority process will kill low priority process. That means what? Others can suspend. Others can suspend current process. Therefore, what is going to happen? The resources of releasing of the resources forcefully releasing of resources. This is what is the meaning of preemption. Especially in preemption only, please understand. In a non-preemption, we don't require much more context switching. But preemption, what is required? Mandatory of what? Context switching. Because high priority is going to kill you, so therefore you need to save yourself and load other selves. So in preemption only, we go for the concept of what? Context switching. Yeah, the first variety. So there are three varieties we want to discuss in today's session. Very fast you can complete, very easy, because I will give you all the rules and regulations. Please see the rules and regulation. First come, first serve. I already told you it is based on arrival time only. So criteria arrival time, and it is a non-preemptive which must not be killed by others. And the very important note is here only. If the arrival time of the two or more processes are same, then you need to select what? The lowest process ID for the scheduling. This is important. So let me give you one example here. You see this example. Before doing that exercise, first understand that I am following FCFS. So P1, P2, P3, they are all arrived at time 0 only. Please understand. All the processes are arrived at the ready queue at the time 0. I required 7, he required 1, he required 2. So we want to continue calculate what is the completion time, what is the turnaround time, what is the waiting time. We want to calculate them. There may be or may not be having a waiting time. That depends upon the arrival time only. Please see. In order to do this particular sum, there is a requirement of what? Gantt chart. So this Gantt chart is for CPU, how the CPU is reacting. That's why we are writing a Gantt chart here. It is only for representation of CPU only. You see that three processes are there. You write the timeline of your CPU like this, and every CPU is always starts with 0. You see that at a time 0, three processes have come. All three processes have come at time 0. Who are they? P1 and P2 and P3. Friends, I told you one important thing. Whenever arrival times are matched, then you need to take what? Lowest process ID process. Therefore, whenever all three processes are arrived at time 0, then immediately we want to see that this has got the lowest process ID. So we will push P1. As it is a non-preemptive, I need 7 units of time to complete this process. Unless I complete it myself, others cannot be preempted because I am following a non-preemptive fashion, as FCFS is a non-preemptive mode. So by 7, the P1 got completed. Now, once P1 are completed, still there are two processes are continuing in your ready queue, P2 and P3. Just you remove the P1 from there. So now that arrival times are the same. Therefore, I am running this time P2. P2 requires 1. Whenever arrival times are same, choose the lowest process ID VLAN. Now after that there is only one process is left. I don't require any CPU scheduling algorithm for one process is in the ready queue. Again I am telling you. If your ready queue has got multiple processes, then only there is a need of the CPU scheduling algorithm, otherwise no. So here I can post it directly P3. I require 2 units of time and 10. Now you see that P2 got completed by 8, P3 got completed by 10. This is your completion time. What is the turnaround time? We know the turnaround time concept. Ending point minus starting point is your turnaround time. So it is a 7 minus 0 and it is a 8 minus 0. It is a 10 minus 0. What is your waiting time? Waiting during this particular time, we know that the process may be under busy with CPU or the process may be under what? Waiting. So waiting time is nothing but the total time you have taken minus your burst time is yours only. So 7 minus, it's a 7. P1 is directly not at all waited because as soon as it come it is assigned to CPU. Please understand. Therefore waiting time is 0. This is 7, this is 8, this is 10. So 8 minus 0, its time is 8 minus 1. So its waiting time is a 7. And this is a 10 minus, its burst time is 2. It is only 2 cycles only busy with the CPU and remaining time is what? Waiting time only. So therefore your waiting time is 8 here. I required only 1 cycle of CPU, but I have my waiting time is how much? 7. So this is your turnaround time and this is your waiting time. Now you see one more question. I am going with FCFS only. First understand FCFS, remaining will be easier for us. I am saying a process number P1, P2 and P3. Please observe friends. Arrival time 2, 6, 10 and burst time is 3, 1 and 2. He is asking find completion times and turnaround times and waiting time too. Now you see, this is a bit confused than the previous. Those who are learning for the first time, please be concentrate. I am writing the CPU chart now. The CPU chart is telling like this. There are 3 processes are there. The processes are P1, P2 and P3. At time 0, nobody is there. Please observe. The process begins with time 2. At time 0, nobody is there. And I can say that what? It is idle. CPU is idle here. The CPU is idle because 0 to 2, nobody is arrived to ready queue. At 2, how many processes have been arrived? Only one process is arrived. That is only P1. You just send P1. As I am using a concept of non-preemptive, unless and until I execute all CPU cycles, others must not come. So plus 3 by 5, I completed. Please understand. And again, by 5, we have come. So this guy has come. So he has come by 6, but right now the CPU is at 5, ready queue, timeline is a 5. So nobody is arrived during this time. So we understand that it is also what? Idle. Now it reached to time 6. Now at time 6, the process 2 is arrived. So you can push the process 2 here which requires 1 unit of time execution. It's got completed by 7. Now it reaches to 7, but see that the next process is arrived at 10. So therefore 7 to 10 nobody is there, the CPU is idle. The CPU is idle, and 10 exactly the P3 is arrived. So we'll process the P3 here, which requires 2 units of time. Therefore total altogether 12 it got completed. So this is important. So how much time is the CPU idle? You see that CPU idle time is how much? Here 3 units, here 1 unit, here 2 units. It is almost all 6 out of your 12. Therefore, you observe that 50% is idle. This is one important point. How much time or how much percentage the CPU get idle. Now let us see CT minus AT, ending point minus starting point. So 5 minus 2 turnaround time is this, and 7 minus 6 is 1, and next one 12 minus 10, it is how much? 2. Now what is your waiting time? Your turnaround time minus your burst time, so which is nothing but 3 minus 3 is 0, next it is 0, next it is 0. As soon as they entered into ready queue, they are being processed, and there is no concept of what? Waiting time. Please observe, whenever it come, it immediately given to CPU. Whenever it come, it immediately given to CPU. Whenever it come, it immediately given to CPU. There is no waiting time here. So this is how. So this is how much? 6 by 3. This is your average turnaround time. That is equal to 2. Okay friends, this is a different question than the previous. You see that there may be a chance of idleness of your CPU. This is your CPU Gantt chart. So using that, now let us start a questionnaire. 2 questions I will discuss on FCFS. This is the first question. Understand? You also can do on yourself there, and you can give me the completion time. So I am writing the Gantt chart of CPU now. You take that there are 5 processes, and it's always timeline starts with 0 only. The Gantt chart will tell you that the timeline process, how the CPU is behaving. CPU behavior is done by your Gantt chart only. So at 0, please understand, arrival times are in proper order. Sometimes they will be in a mixed order. We need to adjust carefully. Arrival time is a proper order. At 0, who has come? P1 has come. Therefore, P1 has executed 3 units of time. So at 3, there are 2 other processors entered into the queue. Who are they? P2 entered and P3 entered. So therefore P2 we are going to run. Please learn like this only. And P2 is executed plus 2 units of time. By 5 it got completed. Next, still P3 is continuing, and by 5 there are 2 other processes have come into the ready queue. They are P4 and their P5. Because their arrival times are 3 and 4, now I reach to time 5. So between 3 and 4 and 5, you know which process to be sent to the CPU. We know that P3, because it is arrived prior than others. So P3 is executed. I require only 1 unit of time. By 6, still P4 and P5 are continuing. No other process are there, and P4 is being sent. P4 requires plus 4 units of time. So by 10 it is executed, and still 5 is P5 is there. I require 3 units of time. It is 13. So by 13 the work got finished. By 13, what is the throughput? What is CPU throughput? This is another very important question. The CPU throughput is that 5 processes are able to complete. Please understand. By reaching the 13 units of time, I have executed, the CPU is executed 5 processes of time. Therefore, the throughput of the CPU exactly by this time is how much? 5 processes. 5 processes. That is your throughput. Now completion time. it is at 3, and P2 is at 5, and P3 is at 6, and it is at 10, and it is at 13. So CT minus AT, so 3 minus 0, that is equal to 3, and 5 minus 1, that is equal to 4, and 6 minus 2, that is equal to 4, and 10 minus 3, that is equal to 7, and 13 minus 4, that is equal to 9. So waiting time, turnaround time minus burst time. So 3 minus 3, that means what? This is your ending point to starting point. How much time I was with CPU? That's what the meaning of waiting. Remaining time is waiting time. So starting and ending time is 3. I spent 3 units of burst time. So 3 minus 3, my waiting time is 0. Others may be having. So my starting and ending time is a 4, but I'm with the CPU only 2 units of time only. So remaining I am under waiting. So starting and ending time is a 4. My CPU execution time only 1. I am busy with only CPU one time. Remaining is a waiting time. It is a 7 minus 4, that is equal to 3, and it is a 9 minus 3, that is equal to 6. So 3 minus 3, and 4 minus 2, and 4 minus 1, and 7 minus 4, and 9 minus 3. This is what is the response time? Response time is nothing but arrival time and the first hit by your CPU. Please observe the P1 hit by CPU at time 0. First hit minus your arrived time. First hit is at 0, and I have arrived at 0 only. So my response time is 0. Next one, P2. P2 first hit by CPU is at 3, but I have arrived at 1. This is your response time. Next, P3 is a first hit at 5, but I have arrived at 2. Next, P4 first hit is at 6, and it is arrived at 3. And P5 first hit is done by at 10, but it is arrived at 4. This is your response time. The main objective of CPU scheduling algorithm is nothing but reduction of response time, reduce of your response time only. So friends, I hope so you understood. If they ask you average turnaround time, we know summation by 5. So this is 3 plus 8, 11, 18 plus 9, 27 by 5. And average waiting time. Waiting time is 8 plus 6, 14 by 5. So 3 important points we discussed, not 3, 4 important points we discussed about CPU scheduling. Reducing of average waiting time, reducing of average turnaround time, reducing of your response time, increasing of throughput. These are all the goals of your CPU scheduling algorithms. Let us look at next question. So we want to take the chart now. Which consists of a group of 6 processes are there. This is a bit tricky. Those who are learning for the first time, please concentrate properly. So there are 2 ways to solve this problem. One way, use as it is these arrival times. Otherwise, you please reorder them your process. So whichever way you are feeling better, you are feeling it. Reorder means what? You can reorder the process. First P4 I need to write here. First P4, its arrival time is 1. Next P2, its arrival time is 2. Next P3, its arrival time is 3. Next P5, its arrival time is 4. Next P6, its arrival time is 5. Next P1, its arrival time is 6. You want to redone once again, you can redone, just shuffle the orders based on your arrival time. It is a very good habit. Please write everything in this format, no problem. You can use burst time also, you can use it. So P4 burst time is 1. and P2 burst time is 5, and P3 burst time is 3, and P5 burst time is 2, and P6 burst time is 6, and P1 burst time 4. You can follow this, no problem, or directly also you can do it, no problem. So you want to do as a first beginner, you please concentrate like this. Change the order according to your arrival time. All kinds of CPU scheduling algorithms, this is a mandatory. You want to go like this, you can go. Otherwise directly you can work out if you are having experience. So first P4 I written because it is arrived at 1. Then P2 is I have written because it has arrived immediately. Then P3 I written because it is arrived immediately. Then next one P5 I have arrived because it is arrived at 4. Next P6 it is arrived at 5. Next P1 it is arrived at 6. According to that I have chosen burst times also. So first one P4 burst time I took 1, and P2 burst time I took 5, P3 burst time I took 3, P5 burst time I took 2, P6 burst time I took 6, and P1 burst time I took 4. Now use this. You observe at time 0 nobody is there. Please understand. I am not looking this because already it is under order only. But earlier program, why I did not do like that, because they are already in order. Please understand carefully. Earlier they are already in order arrival times. That's why I did not do any kind of shuffle. Here I did shuffle because your arrival times are in different orders. So I made it order. So at 0 nobody is there. So CPU is idle. At 1, who is there at 1? Arrival time 1. Who is there? P4 is there. Execute P4 with 1 unit of time. It is 2. Arrival time 2. P2 is entered. It requires 5 units of time. So by 7 it got completed. Next P3, it's already in the queue. Use 3 units of time. By 10 it is completed. Next P5. P5 is the process which requires 2 units of time. So it is 12. Next P6, which requires 6 units of time. It's 18. Next P1, which requires 4 units of time. It's 22. This is how. The first process requires 1 unit of time. Second process requires 5 units of time. Third process requires 3 units of time. And fourth process requires 2 units of time. And next process requires 6 units of time. And next process requires 4 units of time. Now you can post into completion time. So your completion time, P4 completion time is at 2, and P2 completion is at 7, and P3 completion is at 10, P5 completion is at 12, P6 completion at 18, P1 completion 22. You know the remaining turnaround time CT minus AT and waiting time TAT minus burst time. Okay friends, now we will look at into next variety, shortest job first, also called as shortest process first. Its criteria, I have given 4 criteria. It is following one criteria, that is a job size. And this is very important. What is that? If there may be a chance that burst times of the process may be matched, in that case you take the process which has got a lowest arrival time. If arrival times also matched, then you go to FCFS concept, that is nothing but choose the lowest process ID. This is very important point. So let us do now. Please see here, arrival times are already in a proper order, 1, 2, 3, 4, 5. Therefore no need of shuffling here. Please understand, directly you can take it. Whenever arrival times are not in proper order, then you convert into order, then you execute. Otherwise directly also you can do if you are having good experience, but slowly you better you do first conversion. Please observe, There are 5 processes. Take 5 different timing units. Start with 0. Nobody is there with the starting at 0, so CPU is idle. At 1, who is arrived? P1 is arrived. Please observe. At 1 only P1 is arrived. Now you see, you may have a doubt that as we are doing a shortest job first, you are all having a doubt. Why are you running process P1? Actually, shortest job is what? Process 3. Please observe friends carefully. You all may have a doubt that like this. Shortest job first means shortest burst time. Shortest burst time only. You observe that P3 is supposed to run actually because its burst time is only 1. But it is wrong. Why? In your ready queue, you please observe, your ready queue, that particular process is not arrived. Therefore, the P3 is arrived at the time unit of only 3. So therefore, I cannot able to process 3. This is very important point. So process 3 cannot be given to CPU because it's arrived at 3. Right now I am at 1 only. That's why even though the 1 is having a longest burst time, we need to take by force because other process is not there in your ready queue. This is about ready queue I am talking. This is about ready queue. Nobody is there. Here only one process is there at time unit. What is that? P1. Okay. So P1 has got burst time with how many? 7 units. So it is going to 8. So P1 got completed. Friends, you observe carefully. During the 0 to 8, after elimination of P1, many other processes are entered into the ready queue. Who are they? P2 is added, and P3 is added, and P4 is added, and P5 is added. Duration of 0 to 8, all other processes have come. Now you tell me, if a ready queue has got multiple processes, there is a requirement of CPU scheduling using the shortest burst time. Now you understand? Whenever all other process is under your ready queue, now we understand that this is having the shortest burst time. So now P3 is executed with a 1 unit of time. Now you can take P3 because it is in ready queue. Otherwise don't take it. It's 9. So P3 got completed. Now you see between 2, 4, 5, you observe carefully. Between 2 and 4 and 5, the P4 is going to be executed because its burst time is a smaller, and plus 2, it's 11, and therefore it is also completed. Between 2 and 5, its burst time is a 5, its burst time is a 8, therefore P2 will be executed with a 5 units of time, then it is 16. And the last only one process, I don't require any CPU scheduling algorithm because your ready queue has got only one process. What is that? P5. Directly I can send it. It's a 24. So therefore, P1 is completed by 8 and P3 is completed by 9 and P4 is completed by 11. P2 is completed by 16. Then P5 is completed by 24. Reminding you know how to fill. Okay friends, what is the advantage with SJF? This is a very important point. You all have to know that why are we doing SJF? Advantage of SJF is avoiding convoy effect. Avoiding convoy effect. This convoy effect you have got from FCFS algorithm. Is very important. To avoid the convoy effect which is coming from FCFS, we are doing SJF concept and LJF concept. What is the convoy? Please understand. Convoy effect. This is mainly is coming from FCFS. You say that FCFS is non-preemptive and any number of processes you can able to keep in chain. Therefore P1, then after that P2 should come, after that P3 should come, after that P4 should come, and it goes on to Pn. You see that Pn you want to run, so Pn minus 1 should run. Pn minus 1 should run, next Pn minus should run. Likewise you say that They are reverse chaining. It's completely under like a convoy only, car convoy or CJ. So category security convoys. The next process is depends upon your completion of your previous process only. But don't think that this convoy effect is different from your starvation. Please understand, this is one important point. What is the convoy effect? It's a nothing, it's a not indefinite, it is a definite waiting time only. I know that how many processes are there before me. That's what the convoy effect, but I need to wait till the completion of the previous processes. But starvation is indefinite. I don't know that what is my position. So you don't know what is your position, then you are going to be under indefinitely waiting for others. It is a concept of starvation. This is the problem with the FCFS. And one more I want to highlight. Please observe carefully. This is FCFS process number 1 and 2 and 3. Arrival times are 0 and I am taking a burst time as 100, 1 and 2. You please observe friends, as far as this, if I am using FCFS, you see that unless P1 has got completed 300 units of time, please see, at 0 all have come, P1 came, P2 came, P3 came, because all three processes have come to the ready queue exactly this time, but we process only P1 because as it has got lowest process ID, because all arrival time of the process is same. But you see, unless I executed 100 units of time, I cannot touch process 2 and process 3. Therefore, what happened? Then process 2 will begin after completion of that, and process 3 will begin after completion of that. You please observe friends, your throughput, your throughput out of out of 103 units. How many? 3 only. You observe carefully. If I am using the concept with SJF, what will happen? If I am using the concept of SJF, what will happen? So process number 1 and 2 and 3, arrival times are 0, 0, 0, and I am taking as what? Burst times. What is the burst time? 100 and 1 and 2. And now you look at your Gantt chart now. 0, all have come, P1, P2 and P3. Now you tell me, as far as SJF, which process I need to take. If you are in live, please comment. As far as SJF, all processes are in ready queue now. Now tell me which process I need to send it to the CPU. So we know that the process I can able to send it to the CPU, that's nothing but what? 1, because as it has got the least burst time. Now the process 2 got completed. Next, process 2 got completed with 1 unit of time. Now the next process I can begin P3 plus 2, 3 units of time. Therefore, we please observe during 3 units of time, by 3 units of time, throughput is how much? 2 processes. Please observe carefully. But in the previous case, during 3 units of time, what is your throughput? Your throughput is nil. Why? Still the P1 is continuing in execution only. This is the drawback with FCFS. But it is very easy to implement, but the drawback is what? Convoy effect. And the next one is throughput is drastically reduced if you are having the CPU bound process like this. In that case, this is your CPU bound process. So because of the CPU bound process, there may be a chance that during this 3 units of time, the throughput of your FCFS is only nil. But in that case, you please observe, SJF is a superb, because by 3 units of time, I could able to process what? 2 processes. Therefore, your throughput is greater than the previous FCFS algorithm. Okay, friends. So come to example 2. This is for SJF We will discuss two examples. In the special class, we will discuss more numericals. Please understand. So here, your arrival times are not in a proper order. Therefore, you want to directly do it, you do it, no problem. Otherwise, you want to change or you want to shuffle ascending order, you can shuffle it. So I'm shuffling. Please understand. Process number, arrival time, and burst time, and completion time. If you know up to this remaining, you can carry on. So first arrival time is a P4. Is arrived at 1 with the burst time 5. And next process is a P5. It is arrived at 2. Its burst time is 2. Next arrival time is a P3. Is a P2. It's arrived at 3. Its burst time is 3. Next arrival time is a 4. That is done by P3 and which requires 6 units of time. And next arrival time is a P6 which is arrived at 5. Burst time is a 1. And the last one is a P1 which is arrived at 6, burst unit as 1. Now you tell me the Gantt chart now. So we want to execute based on shortest job first. We want to execute based on shortest job first. 0, nobody is there. Therefore CPU is kept idle up to 1. At 1 we have come, P4 come. So post P4. So I require 5 units of time. It is 6. You are having a doubt once again. I am recapping. Once again you are having a doubt. This and this having the lowest burst time. So I supposed to execute P6 and P1 only. But certainly not. Why? They have arrived at the time 6 and they have arrived at time 5. They are not in ready queue so far. So at time 1, only one process is in ready queue. What is that? P4 only. Please observe. The processes which are there in ready queue only we will send it to the CPU even though respective of their shortest burst times. Even though it is having a shortest burst time, you see that that process is in this particular ready queue or not. Right now in ready queue there is only one process, that is P4 is available. That's why we push the P4 irrespective of its burst time. So I require 5 units, by 6 I got completed. And now you see during the 0 to 6 time, please observe, during 0 to 6 time all the process have come. 2 it has come, 3 it has come, 4 it has come, 5 it has come, 6 has it come. Now there is a problem. What is that? Between P5 and P2 and P3 and P6 and P1, we want to see that which one to be executed. Now you need to go for what? Shortest order, because all processes are in a particular ready queue only. Whenever ready queue has got a multiple number of processes or more than one process, then there is a need of CPU scheduling. If there is only one process is in ready queue, there is no concept of CPU scheduling, just assign to CPU only. There are more than one process are there. Now I am using the shortest job first. So in the shortest job first, this is having a least burst time, this is having a least burst time. Whenever burst times are same, now I am in ambiguity which process I need to send. So you need to take what? Arrival time, lowest arrival time. So as between P6 and P1, there is a tie in the burst time. So we are choosing a what? Lowest arrival time. So P6 will be pushed, which requires 1 unit of time, by 7. This is got completed and this is got completed. Now we are assigning next immediately P1 only, which requires 1 unit of time, and it is 8. Please observe, whenever there is a tie among the burst time, choose the lowest arrival times. Next lowest arrival time. Next see, please observe, there is a tie between these three. Why tie? Because all three processes are in ready queue only. Now you see that this is having a least burst time. Now I am sending a P5 which requires 2 units is a 10, and it is done. Next we have next least burst time is a P2 and which is executed plus 3 units of time. So by 13 it is got completed. Now only one process left. What is that? P3, which requires 6 units. It's 19. Now you tell me P6 got completed by 7 and this is got completed by 8. P5 got completed by 10 and P2 got completed by 13 and P3 got completed by 19. So now you see there is an audience question. If all processes are having a arrival time 0, then you need to go according to FCFS only. Please understand, if burst times are same, lowest arrival numbers. If arrival times are also same, then lowest process ID. We have to go till reach to FCFS. FCFS is the last algorithm to finalize which process we need to push to the CPU. Please understand, if burst times are same, if burst times are same, for example 1 1 1 P1 P2 P3, and we are looking at arrival times also same, then we are looking what FCFS order it is going. So now in this case SJF order is FCFS order. Simple as that. Now come to LJF. Before LJF, first let us understand few things. FCFS advantage. What is the FCFS advantage? Easy scheduling algorithm. The disadvantage we understand, convoy effect, but it is not a starvation. Please understand difference between convoy and starvation. Convoy, I know that how many processes are ahead me, but starvation we don't know. One more disadvantage is there, throughput is less in case of previous processor CPU bound. Previous processes are CPU bound. And these problems are avoided in SJF. What is SJF? You please observe shortest job first. Advantage is superb. No convoy effect. And the second advantage is that you can increase the throughput. Throughput is increased. Just within a few number of units only you could able to complete more number of jobs. But there is a drawback. What is the drawback? Starvation. Starvation to longer burst time jobs. Longer burst time jobs. Please understand, it is suffering from starvation now. And the next drawback is realistically not possible to implement. Not possible to implement because of calculation of burst times. Calculation of burst times. So you want to clear this problem. What is the problem? Starvation to longer jobs. We are using the reverse strategy. What is the reverse strategy? We are using the concept of longest job first or longest process first. It's a very similar to SJF only, but we will take longer jobs first. It's a non-preemptive fashion. Non-preemptive fashion means once the process is assigned to CPU, which must not be preempted by others, you have to release resources voluntarily, not by forcefully. And this is very important. What is that? If the burst time of the process are matching to each other, then you take what? Lowest arrival ID only. Now let us take, what is the advantage here? No starvation to longer jobs. Please understand carefully. But there is a disadvantage. What is the disadvantage? Reverse. Starvation to shorter job. This time it is going to give starvation to reverse shorter jobs, and this is also not possible to implement real time. Not possible to implement in real time because of calculation of burst time. Because of calculation of burst time. So how to be done a problem in this? Let us see now. The first problem, using longest job first. You please understand, it's already in a proper ascending order only. No need to shuffle them. The arrival times are proper order. Just take the Gantt chart and push it that. There are 5 jobs. Take the 5 blocks. Luckily, CPU is not idle because it's starting with 0. The process 1 is in ready queue now. Please understand, here also I want to give you one clarity. As I am executing longest job first, I supposed to execute longest burst time job only. But here longest burst time job is a 6, that is a P5 I supposed to be given. But no, you cannot give P5. Why you cannot give P5? Because P5 is not in a ready queue at the time of 0. Please understand. At the time of 0, only one particular process is in a ready time. That is what? P1. This time, irrespective of your burst times, we are going to execute the process 1 because the process 1 is in only the ready queue. Others are not there. So we want to execute the process 1 by force, no doubt. Because whenever only one process is in a ready queue, there is no requirement of CPU scheduling algorithm. Therefore, it takes 3 units of time and just get executed. Next, duration of 3. Please observe carefully. Duration between 0 to 3, other processes have come. What are that? P2 is arrived by 1, P3 is arrived by 2, P4 is arrived by 3. So I can consider all the 3 processes. That is, P2 is there, and P3 is there, and P4 is there. Duration of 0 to 3. Please observe. So 3 more processes are entered into the ready queue soon after completion of your P1. Therefore, we want to see that among these 3 which are having the highest burst time. Now, whenever the ready queue consists of more than one process, then there is a requirement of what? CPU scheduling algorithm, and that too the CPU scheduling algorithm short-term scheduler are using a longest job first among these 3 which is having the longest job. Now the problem come. So the longest job has got P4, so we schedule P4 first. And therefore P4 requires 5 units of time. So by 8 it got completed. So by 3 it got completed, by 8 it got completed. Now there are other processors also there. P2 is continuing and P4 is continuing. P3 is just recently completed, and duration of 0 to 8 other process also have come. Please observe carefully. Earlier it was not there, 0 to 3. Now 0 to 8, the time is expanded. Now duration of that one more process is also entered by name P5. So we want to take it by 6. It has entered into the ready queue. We want to take it. Now among these 3, which is having highest burst time, P5 has got highest burst time. So we want to execute P5 here, which requires 6 units of time. By 14, it got completed. Now there are other 2 processes are left. What are they? P2 and P4. So among this and this, P3. So one more process is also there. So P2, P3 and P4. So P4 already completed. Now P3 is left. So now there is a race between your P2 and P3. Now you see that between P2 and P3, the P3 burst time is a mature. Therefore P3 is a schedule which requires 4 units of time. So by 18 it got completed. There is only one process is left in the queue, that is P2. You can send it directly. So 2 units, by 20 it got completed. So this is how. This is a little bit tricky question. Why? Because P5 is not been added initially after completion of P1. We have been added at later. So this is how you can solve longest job first. And the last example for today class is this. Now you see, they are not in a proper shuffle order. You want to directly write. Now I am doing directly. Please observe. You can also do directly. Even though you please observe, they are not in a proper order. Your jobs are not in a proper order. At 0, nobody is there. Please observe carefully, friends. Your arrival times are in different orders, but we would able to do instead of reshuffle them. Directly I am doing. At 1, you observe only one process is arrived to the ready queue. That is a P2. Even the irrespective of its lowest burst time or shortest burst time or longest burst time, we are going to execute it. So it's got completed 1 unit of time. It's 2. So duration of 2, who other have come? Please observe. Duration of 2, it has come 3, it has come at 4, it has come at 6, it has come at 2. Now there is a competition between P3 and P6. So therefore, we will see that P3 is added into the queue and P6 is added in the also queue. Whenever there are more than one process is there, then the CPU scheduling algorithm uses LJF algorithm as we are following LJF. Now you see that which has got highest burst time. So P1, so P2 has already got completed by 2. Now there is a race between what? P3 and P6. It has got a more longest burst time. So P6 is going to be processed plus 4. It is a 6 by 6. It is got completed. You remove this. Next, you please observe after P6 is removed, your ready queue is having a P3. Now again you decide 0 to 6 other processes also have come. Who others have come? Please observe. Already P3 is there in queue. You see this at time 3 this guy have come. So that is a process P1 is entered. Then who else also entered? P4 is also entered and P5 is also entered because 0 to 6 process P1 arrival time 3 added and this guy is added and this guy added. All process now are in ready queue. Now we want to see that which is having the longest burst time among these 4. So you see that this requires 3 and this requires P5 requires 6. This is only the longer. So we are going to process what? P5. So which requires 6 units of time. By 12 it got completed. So remove P5. Now the race between 3, 1, 4 only. So 3, 1, 4. It requires 3 and which also requires 3, which requires 2. Now there is a competition between this and this. Why? Burst times are same. Whenever burst times are same between P1 and P3, we are choosing a what? Lowest arrival time. This has got arrived lower than that. There is a tie in the burst time. So we are choosing the lowest burst time. So lowest arrival ID, that's a P3 we are going to process. So P3 requires 3 units of time. Therefore, by 15, it got completed. Now in the race, P1 and P4 is there. So P1 requires 3, P4 requires 2. Therefore, it is having a longest burst time. There is no tie. Therefore, P1 is being processed plus 3. It is 18. So by 18, it got completed. Next, the last only one process. No scheduling required. That is plus 2. So it is got completed by 20. So this is how you can directly do the problem using this. Otherwise, you reshuffle the processes along with your arrival time. So arrival time, who first P2 has first come, then after that, and P6 has come, arrival time, then after that, P3 also arrival time 2, then after that, what is the next process? This guy, arrival time 3, that is a P1 3, and after that P4 arrival time 4, after that P5 arrival time 6, and write the burst time according to and do it, no problem. So you also will get the same order. So either you reshuffle them according to ascending order or directly you could able to do the problem. Okay, so now you understand one important thing. What is the important thing is that here we have learned whenever burst times are same, based on the arrival time it executed, if arrival times are also same, we will look at what? lowest process ID. Don't think that it is the highest process ID as we are using LJF. Please observe this very, very important point. This point is that this is the common point. This is the common point between SJF and LJF. What is that common point? Whenever burst times are same, whenever burst times are same, we are going to pick the process which are having a lowest arrival time only. It is common to SJF as well as LJF. Don't think that as we are facing a longest job first, so we have to take highest arrival time process whenever burst times are same. That's wrong. So this is a common point to LJF and SJF. Well, friends, so we have completed up to today's session three non-preemptive scheduling algorithms we learned: FCFS, SJF, and LGF. In FCFS, we see the problem of convoy effect, but it's not a starvation. It's not that much dangerous too. But the only problem with FCFS is what? Throughput is decreased. So to avoid that problem, we process first either shorter jobs or longer jobs first scenarios. Therefore, throughput will be increased and the CPU bound process will be kept aside later. So, but there is a problem with SJF and LJF. What is that? You cannot able to implement this in real time because unable you it's very difficult to calculate your burst time, but assumptions are there. What are the assumption? You can calculate the burst time of SJF and LGF by assumptions. What is that? What type of process it is? What is the size of the process? Size of the process is nothing but what you know. When you download a file or a movie, it will come to know that 300 MB or 200 MB. So based on that, I may choose which is the shorter, which is the longer. So based on the process size, I can decide which is the shorter job, which is the longer job. Or based on the process type is nothing but if it is a text process, it's a small. If it is a audio, it is a small. If it is a video, it is a bigger. If it is an image, it is also bigger than your text. So based on the process type, you can decide. Based on the process type also, you can decide whether it is a shorter job or a longer job. Text is a shorter, first shorter, image is the next shorter, audio is the next shorter, video file is a higher one. So otherwise, process size, it is in the KB or MB, you decide which is having the shorter. But instead of static method, we also can go for what? Dynamic method. Dynamic method is nothing but simple average technique. The burst time of the next process is nothing but one summation of all your process divided by number of process only. It's very simple. Summation of all burst times of previous process divided by number of process. So you will get one on an average. So that one also you can able to calculate. That's called a simple average. And the next one is exponential average method. And nowadays people are using exponential average method only. What is that? The burst time of the next process depends on your actual burst times and predicted burst time. Here, capital T is nothing but predicted burst time, and small t is nothing but actual burst time of the previous process. Your alpha is a smoothing factor. Your alpha is supposed to be always 1 by 2. That is nothing but 0.5. So using either of these techniques, four techniques are there: process type, process size, simple average, exponential average. You can able to calculate your burst times. That's it, friends. This is how, but it is not possible realistically. SJF and LJF we don't prefer. We prefer nowadays algorithm. I want to tell you nowadays which algorithm we are using, friends. Among all the algorithms, which algorithms we are using? Please comment. Among all the algorithms, which algorithm right now we are using? Which CPU scheduling we are right now using among all these algorithms? I have mentioned around 10 algorithms. So which algorithm we are using right now? Right now, all your operating system, including mobile, are using which algorithm? The only one algorithm. What is that? You can just type it from comment. The only one algorithm that is called excellent round robin as far as desktop concern and laptops concern and servers concern. But you see, mobile, when you are talking a mobile operating system is using RR as well as it is following what? Priority. So your mobile operating system is based on a round robin. It do the multitasking, and apart from it, does round robin does that priority also it is included, because you see WhatsApp is giving high priority, phone call is giving high priority. Therefore, your previous process is going to be paused for some time. So therefore, the mobile operating system is following both multitasking round robin as well as a priority also it is following. That's why you see that notifications are in prior are appeared than your earlier processes. Okay, friends. So I want to finish off the today's lecture. Today's lecture, I want to finish off using like this. You say that we are having nowadays multiprocessor systems. So this is the last finishing point. So what is the multiprocessor concept? You say that there are multiple number of processors are there. CPU 1 and CPU 2 and CPU 3. But naturally, how many CPUs you people are having in your desktops and laptops? Please respond. CPU 4, CPU 5. How many CPUs? How many CPUs are there right now with your desktops? You may be using your laptop or desktop. How many CPUs you may find? Is it a one or many? How many CPUs you may find in your desktop or laptops? So many of people are knowing that we are running with only one physical processor. Please understand. One physical processor. As far as desktop and laptop concern. But you see, as far as server concern, there are n physical processors. Google servers, Yahoo servers, YouTube servers, they are all having a what n physical processors. If one processor fail, the system won't stop. Immediately switch over to next CPU. If that CPU fails, system won't stop. Immediately it goes to the next CPU, right? So therefore, we are running right now with n processor systems in real-time environment. Even IRCTC is following, other database is following. All databases are having backups called as hot swaps. Now one more thing, logical processors I am talking. Your desktop is having one physical processor, right? Your desktop is having one physical processor, as we all agree, but it is logically divided into multiple parts. These are called logical CPUs. Yes or no? Logical CPUs. Logical CPUs we are having. That's what the meaning of what? Octa-core or Hexadragon. Your mobiles. You see that octa-core is nothing but what? It is having 8 core parts. This is where you see the threading concept. The main concept of thread will come into this kind of situations only. Whenever you have 8 cores or 16 cores or 32 cores, each thread is been assigned to each kind of logical processor. It may not be a physical processor. It may not be a physical processor. That means when I'm having 8 core parts, you see that I could able to do 8 tasks at a time. 8 tasks at a time. Please understand, that's why in mobile you're able to see that multiple tasks at a time. Even I can do WhatsApp, I can listen songs, I can do audio, I can do audio. So that's why your previous process is not completely shut down. It is a slowly running only, because you are having the concept of what? This, what are logical CPUs. Logical CPUs, when you talk, one physical process is divided into multiple cores. which starts from dual core. First one is a dual core, then it becomes octo core. Nowadays we are running with the 16 logical CPUs. That means at a time you could able to do 16 threads at a time. So you see that how you could able to do multitasking operating system nowadays because of using a what? Even a single process, I could able to do multi-threading or multitasking operating system. Well, friends, so tomorrow session, evening we have a special class. I will send a message to all of you. Please don't miss. There are many kind of numerical problems we solve in the evening classes on Unacademy student learning app. Tomorrow our schedule is preemptive based scheduling algorithms, and keep on next 20 to 30 days. We are dealing with one by one topic, which including very good topics also, process synchronization and inter-process communication and multi-threading concept we will learn during this 30 lectures of operating system. So subscribe to Unacademy channel. If anybody not yet got admission in Unacademy, please join using my referral code. I will also come for another subject, that is computer networks, and one more if possible TOC and CD also. So don't worry about the completion of the syllabus. Give your admission happily, and please subscribe to our channel. Give a like to every of my video because I need likes, and give comments also. So all of my friends, those who are watching online, please like my videos. Thank you very much.